Okay, well, thank you for having me. My name is Emil Lybaek Jacobsen. I'm a PhD student at Aarhus University in Denmark, and I'm here to present on behalf of myself and my co-authors Ingvild Moelmen, Haavard, and Jochen Teizer. And our research here is about asymmetrical multiplayer series games and Vibrotactile haptic feedback. And this is used to train workers in overhead crane load scenarios. So in the construction industry, we see a lot of fatalities, and there has actually been an increase in fatalities in construction, as stated by the Bureau of Labor Statistics in 21, as we also see here on the right. And when we look at injuries that are involving cranes, we see that most of them are struck by accidents. Also from the Bureau of Labor Statistics in 19. And most of them happens within what we describe as the danger zone. And I'll come back to what that is in a few slides. And this was stated by a Norwegian company called Arbeidstilsynet. We also see the statistics down here from Norway being a lot less than they are in the US, obviously. So for serious games in VR, current research for hazards is divided into two different methods. It's either automated pathing of hazards, as we see in Golovina et al. From 19, where both the skid steer loader and the crane has been pre-programmed to follow a path, and that makes the hazard very predictable. We can also look at the other category using static hazards. So this is, for instance, the work by Solberg et al. From 2020, or our own work, Jacobsen et al. From 21, where we use, for instance, hole in the ground or leading edges as hazards. The reason to use VR has been widely researched, especially for training and education, where we see that VR both increases learning interest, it increases engagement and motivation, as well as improve awareness of hazards, and it enables us to do performance measurement because we can collect unbiased data through these virtual reality environments. If we then look into asymmetrical VR, which is a subcategory of VR, it allows us to use different levels of immersion. So a player can be within the VR environment with a head-mounted display, but someone could also join using a desktop computer or even a smartphone. And this overcomes some of the platform-dependent limitations as stated by Chow et al. In 15. And it also enables instructor-student feedback, as stated by Lugrin et al. From 16, because it allows us to do instructor views for the VR experience, as I'll show in a later slide. And one of the biggest benefits are that we can actually have a lot of people in a virtual environment without having the expense of using tens of VR devices. So for our scenario, we have 2 VR stations in separate rooms, and they both use the HTC Vive Pro Eye, and then we have a PC station, and these 3 are completely separated. So to make this possible, we use what's called Photon unity networking. So this is what makes this inner circle work, to connect all the clients to one shared network. And we use Unity 3D to model the experience. And then because we are researching Vibrotactile haptic feedback, this is programmed in Unity in C#, and it uses both the vibrations and sounds, as both of these are seen as very important factors when we look at immersion in VR. So for the implementation, we have 3 players. We have the crane operator here on the left, and the crane operator uses a keyboard to control a crane, which is seen in a view on a PC screen. Then we have the worker, and the worker is using both the VR but also a body motion suit, so we can actually track his movements and not only the hand movements, because we have all these IMU sensors on the body. The last person is the Health, Safety and Environment Coordinator, the HSE, and he's located in a different room. Effectively, all 3 could be in different rooms, but for this specific experiment, we have a shared room due to logistics. So for the different tasks, we look at the crane operator first. The crane operator needs to move 4 boxes into the zone stated as 9 here. And because they need to be put in the same order as they are currently, we have also made a temporary loading zone. So the crane operator can move a box to this loading zone before it moves to number 9. For the worker, he obviously needs to be safe, and that's why we have circled number 3. He needs to wear the hard hat. And besides that, he needs to do the placing of drywall sheets in number 4. Then he needs to place the toilet and sink at 5. And then behind this wall, he needs to place the pipes to the toilet and sink. And then in number 7, he needs to do some overhead work, hanging up lamps and install the wires to the lamps. For the HSE coordinator, he needs to obviously be safe as well. So also we have marked the hard hat. And then he needs to clean up the warehouse. So we see a lot of small stuff like the hammer here, or the oil barrels, or the paint cans. These needs to be cleaned up and put into the storage area, which is marked by 8. For the haptic feedback, we have given this to half of the participant groups. So we have groups with and without feedback to assess the haptic feedback and if it actually does something. And this is used, the haptic feedback is given both for the short range, so when people are underneath the crane, as we see here on the right, but also for the long range, so when people are what we determine as the danger zone. And we have made this as a sliding variable. So for this experiment, we have chosen 2.52 meters because this has been used in all the research. But this can obviously be changed very easily through the Unity. And we also give haptic feedback for the robot arm station proximity. So if people go within this zone, this is also given as haptic feedback. So what we see here is an example of a round, and we see on the right is the player view, on the left is the instructor view, and this player is currently installing drywall sheets. And what we see when he comes down here is that he actually experienced the haptic feedback. So now the crane becomes close to him, and he starts to look around because he can feel it in his controllers. So he tries to look for the crane if it's near him, and he spots it and moves away. And we actually see they try to communicate there in the end, saying, watch out for the crane, or whatever they're trying to say. For the results, as I stated, we have 9 groups, each of them having 9, or we have 2 groups, sorry, each of them with 9 participants. And what we see in group 1, where we have the haptic feedback disabled, is that the pathing of the players are very chaotic, and there's not really any frequent pathing. But this changes when we enable the Vibrotactile feedback. And these 2 groups are completely independent. No participant has been in both groups. So the ones that experience haptic feedback doesn't experience it without it. And what we see in the enabled group is that player pathing is a lot more concise and very frequent, and it's often very far away from the crane path. And this obviously leads to less encounters with the crane. And just to visualize it, I have here on the left, I have it without haptic feedback. On the right, it's with haptic feedback. And when we look at the left image on both of these, we can see that the player pathing, the worker trajectory, is a lot more frequent in the one where they get haptic feedback. And this leads to these small dots being a lot less on the right. These are danger zone encounters, and there's also underneath crane encounters here. So to put this into perspective, we have the 2 groups. We have without haptic feedback, and then we have with haptic feedback below. And what we can see is that if we compare them, we actually see a big change, a very significant change in especially duration. So how long are they actually within these zones? We see a 35.4% decrease when using haptic feedback in what we call the danger zone, and very similarly, 31.4% decrease when we look at the underneath crane, so directly underneath the crane. For future research, we would like to also assess the ergonomics of participants while they are in the zone, and that's why we actually have the body motion suit on one of the players. This will allow us to look at bending during activities, and also, as I stated, with the lamps overhead work. This also allows us to do full body avatars due to the many sensors, and we also would like to look at crane detection. So not only to assess whether the player is within a danger zone, but also have he actually looked at the crane and see if there is a correlation between haptic feedback and crane detection. This was my presentation. Thank you for listening, and